All right. Hello, everybody. Welcome to the Elasticsearch meetup in Berlin. My name is Ale. I've been working in Zalando for almost 3 years. I'm responsible for a lot of data engineering topics. I work in a team where we're responsible for product data and presentation. I'm sure everybody knows about Zalando. And our team responsibilities is about presenting data for customers or providing backend infrastructure to serve data for customer-facing applications or for other services. And lately in Zalando, we've opened up to the open source culture and community. We're now open sourcing a lot of our projects. And this is part of our contribution, is to share with others what we're doing, what we've reached, and how we set up our technologies. And from this, I would also ask everybody who has something to share, whether it's a data solution, whether it's a search problem, or anything that you solve, is to share it with others. And that's why we created this meetup. It is dedicated directly to Elasticsearch, but feel free to share any data-related topics as well. So, since we are having a database night, I would like to share with you a bit of the technologies that are in the market. And lately, in most of the e-commerce websites, the challenges that we deal with are about scale, handling quality data, consistency at large scale. And the technologies on the market offer a lot for different use cases. And to just remind you of something, maybe you've seen this in university or have seen this across your, in your work. This is a CAP theorem, which states that every data store can only satisfy two sides of this triangle. And this triangle talks about consistency, availability, and partition tolerance. And this is a diagram that states where the database technologies currently on the market try to optimize and focus for. And as a data engineer, you're required to use the best solution for the fit of your use case. And in Zalando, we've learned a lot that studying your use case and really looking through what you need to do and putting the right technology in the right place in the architecture plays a very important role in success. To have a look, so consistency and availability, in the past you had the old school databases, the normal relational database where your problem is about just, your traffic is very low and you just need to save data. And in this case, it worked very well until you had large traffic and you needed to scale up. And in this sense, these databases could not scale up with you because every time you needed to scale, you just buy a bigger hardware. And that's why it created the room in the market to create the other databases to go in the direction of more availability and partition tolerance. And that's why you can see the names like Cassandra or DynamoDB comes now in every company. We can hear the success of such technologies into building scalable applications. Elasticsearch is one data store that stands out completely different from these technologies because it offers much more than just fetching data or saving data. It is much more than just a database. It is, if you just open and check, read the manual, it says a lot of buzzwords like RESTful, distributed, scalable, or queryable. It are all buzzwords, but it does not describe what Elasticsearch is. It is actually a search engine, and this is much, much more than just a database. I know there must be some people here that are new to Elasticsearch, so that's why I wanted to incorporate a little bit of what we do in Zalando, but before to talk about how we solve fashion problems is to give an introduction of the capabilities of Elasticsearch. There are a lot of use cases that we can cover, but it does not fit definitely in one talk. So my favorite topic is the search problem, and this is how to describe how Elasticsearch works as a search engine. Our main problem in Zalando is to match customers with a set of products that we have. We have a growing set of products, and we need to deliver these products to the customers at very large scale, at very fast speed. And usually the customers give us a chance to describe a certain item or something that they're looking for with few little words. And we are supposed to find items that match what the expectations of the user. And the user will not come to you, in a normal database where the user will not say, hey, select from table products, where color is red and category is t-shirt, and you find these documents. That's how it works in the relational world. But in a search engine, it's much more unstructured. You get just text, and you're supposed as a search engineer to make a query out of it to find in different places in your items what exactly is the category or what exactly is the color. So it needs understanding of the query input. So you have your search engine, which specs you up with a database that offers you this restructuring of unstructured queries. The user enters these few words, and what is required in the backend? You, as a search engineer, you're required to fetch this data from, definitely it's saved in a relational database, a very normal database that you're used to, and you're responsible to take this data out, reformat it, remodel it into the beauty of the search queries, and then ingest it inside the search engine. Usually this data is enough for search, but is not enough for high quality search. So you need to enrich much more data to describe the items much more. So the relational database had specific attributes just describing this item. But you need much more subjective data about these items that you store. And that's why you need to go to other places, other databases, other services, or even ask the user to write you feedback about these items to get more enrichment of the items that you're describing. Or even go far to crawl the web and find more information about these items that you store. So far you enriched the product data. For example, in our case, you enriched more subjective attributes about this product data. This is all a process of teaching the search engine and training it to describe the items within. And the other problem is not just writing data from different places, it's about also fitting this data for different user groups. So your user group can tend to be completely different, and different user groups call things in a different way. For example, if you have medical doctors or businessmen or taxi drivers or fashion bloggers or criminals, whatever your user group is, you should be able to match what the user would describe a certain amount of item, what vocabulary they will use, what kind of description they would give you for these given products that you save. And for me as a search engineer, I don't know much about fashion. I really don't care what people call things. And for me, I need someone to tell me what this user group called this, or how would they describe this item. I need someone to represent this vocabulary and an idea of this user group. And that's why I need a content curator or someone to represent the different user groups. And also someone to represent the business values of my stakeholders. So my stakeholders are interested to sell for some brands more or do some promotional campaigns. And this is the product side of the search organization. Back to the user who just asked for a red basketball t-shirt. We've done a lot of work to ingest the products, to enrich the data, to describe the things for different user groups. Now it's the time to return the item for the given user. This is just talk. This is the normal use case of just building a search engine, or this is what the user expects. And Elasticsearch is not a tool out of the box that you just hook up and just send some data and you expect just relevant result sets. It would never work, and luckily it's not this way. Elasticsearch is a toolbox for the lot of tools that will allow you to enrich and teach the search engine to know more about your user and the representation of the items stored within. And to have a deeper look, how would you extract features of a certain item? If you have a product, it's not just pure text what you get in. It's this text represent features, and you need to take these prominent features and turn them into something that you can compare to the user queries. And I had, just to take an example, I had a colleague of mine who just joined the company, and he's about to suffer his first Berlin winter. And he came to me and asked, I need a jacket that is long and has a hoodie. And the first thing that popped into my mind, I'm not into fashion or anything, but I just knew from a long time that these type of jackets are called parka. And I told him, just go online, search for parka. But wouldn't it have much more sense if he just goes and describe this item and say, long coat with a hoodie? This is what I expect from a good search engine. So you can either give a word that goes to a certain user group that the fashion guys would know, this is called a parka, or you can just describe what it is. And in both sides, the search engine should find the result that you were looking for. Now, you get this item from a certain database, or you fetch the item and you get some text from some fashion guy who described it in saying words like, this parka is from sturdy cotton, classic army green, and comes with a removable wool gillet. So this is just pure text, and for the reader, it is text, but for the search engineer, it contains a lot of prominent features that you need to extract from here and make something useful out of it. And to do this, you need to get the important tokens out of it. You need to tokenize this to learn it. So these tokens actually represent the features that you're looking for. And what Elasticsearch offers you is that you can create your own pipeline to transform text into a stream of useful tokens. And this process is through defining a certain analyzer. An analyzer is just the pipeline that processes this text. It contains of 3 components, and you can add from these components different types. So the character filters, the tokenizer, or token filters. I will just give some examples on these components and how you can use them, but there are much, much more. Just go and read the manual. So for example, the char filters work as on character level, where you can just map and transform symbols into words like this, for example. Or the HTML strip filter, if you're building search for searching into websites or HTML markup, you can strip out the useless HTML tags. Going next, after processing some characters on character level to clean up your text, you have the tokenizer. And the tokenizer is about splitting this text into real tokens. And you have different types of tokenizers. You can also define your own. So a very normal standard one is just use the whitespace tokenizer, which just split the words on whitespace. Sometimes it's not enough. You need a harder or sharper tokenizer that you can define your own. This one is, for example, is splitting on anything that is not a word. So it would split such text into 3 different words. So what we've done with the tokenizer so far, so we cleaned up characters, we transformed them into a different way, then we tokenized our text, but now we need to filter the tokens into actually finding the real value of the features. And one important token filter is the stemmer, which takes back the word to its original. So words like playing, played, or player tends to go back to its original root stem of the word, which is just play. And with this, you're just capturing the meaning of a word, and not just the word itself. And that's what you need to do. Then you have the shingle token filter, where you define the size of the shingle, and you get a text like this. Please divide the sentence into shingles. And based on the size, you can create different combinations of the size of 2. And this works very good, for example, for first name, last name, for searching for names. Finally, you have the stop token filter, which filters out words that are just fill words in your text, and they just create noise in your index. You don't need really to have them in your search. It does not affect the meaning. One last one is the synonyms token filter, where you create a relationship between different words and their meanings, which you can choose. So for people, for example, cuisine and food, people would search for Asian cuisine or Asian food should produce the same result set. And this is you mapping the tokens and giving them a meaning into how the user groups would call them differently. Just to give an example how you can create your own pipeline for producing these tokens, it's just you define your own analyzer. Just an example. So we set up an analyzer with HTML strip filter, whitespace, stop, stemmer, and synonyms, and get a sentence like, in the USA, anyone can become president. And that's the problem. Setting the analyzer is as easy as just describing this JSON. So you say, this is my analyzer. I have these stop words. You can define your own or use the default English stop words. And then you define a stemmer. And there's default stemmer for every language. And you can also define your synonyms to represent your group, your user group descriptions. For example, USA maps to America. And then you decide you group the pipeline together, and the order matters a lot how you do it, because you need to process, this is a steps process, and you need to process it in the right order. So you created your first analyzer, and if you pass this text to it, then it creates this type of token. So America, anyone, become president problem. And this filtered a lot of words out. It did not keep the meaning, but you can still match the user queries to this kind of text, and there's a lot of tricks to match against this and this together, and to be ordered to capture the meaning and still capture the original text as well. Finally, back to the Parker jacket. You just flow this text into the pipeline, and you get out of it the set of tokens that describe what this Parker is about, the prominent features that you need to perform your search against. It's all about tokens. And if you think about it, just a thought, what Google actually did is they just tokenized the whole world completely. And it breaks my heart to see that people go, instead of going on our Zalando search, and they just go on Google and write Zalando white sneakers, instead of coming on our page, where we can invest a lot in our search engine, and they just go to Google and do it. Now it changed. Now everything will change. We're building a new search team that is dedicated to find the user intention, that is dedicated completely to find the best result set based on the user personality, based on a lot of machine learning and a lot of data science that will hide behind that. And Elasticsearch will help us do this as well. Back to the analysis problem, creating the pipeline. So you created now your first analyzer, your first token pipeline, but this goes for one text field. You have different fields. So you describe a certain item, like the jacket, in many different ways. You have prices, you have sizes, you have a lot of attributes. And for each attribute, you need to create its own analyzer to find the features that belong to this attribute. For example, if you're searching in acronyms, you need to strip out the dots, the dashes and stuff. If you're searching in telephone numbers, you have to accommodate for the different user inputs the user can give you, because the user can put brackets, can put plus, can put double zeros, can search without the number, can search without the code. And for all these different variations, you can use a pattern with just a regular expression that creates all these tokens and just match against the user input. Finally, with names, I mentioned the shingle filter, which you have then the different variations, where people can call first name, last name, or first name, letter, last name, or first name, middle name, last name, and so on. You need to create a lot of tokens to just accommodate for what the user will be doing. In the end, you end up with a lot of fields that describe a certain item, and every field has its own analyzer to find the prominent features that would describe your item. So Elasticsearch gave you a set of tools. There's a lot of science behind these stemming algorithms and all these filters. And the good thing that it puts all these tools in your hand together, that you can use them to find these, to do this feature extraction. And it's not only about text, so you can use Elasticsearch for searching with images or videos or audio. And it's about, again, finding some way to find prominent features and tokens from the given input stream. And this is only part, actually, of the story. So now we've done a lot of data enrichment. We've ingested a lot of data inside Elasticsearch. We've taught it to represent the expectations of our users. We've done a lot of things to train it how it should work. But the other part is actually fetching data. This is the second part of the story. And to do this, we have to know more about the art of ranking. So for Elasticsearch to rank, you have 3 different techniques to create a good result set. You have to do filtering, boosting, and scoring. And you have to combine the 3 together in a way that is relevant for your customer. Let's take an example, a user that just goes and says white sneakers. He already gives you a color and a category. This is the user input. So the user is expecting a lot of relevant results out of it. He did not tell you there's a lot of missing parts of the query, but you need, as a search engineer, to fill the parts yourself. So you have a lot of data that is fit for a lot of users. So you need to complete a little bit more. The user needs not to say, I want the new arrivals. You can accommodate for that and say, I expect that recency would play a factor in the fetching of result set. You can say that the price range, where the customer usually always pays, plays also a factor on the result set that I will return back. Stuff that that you can make assumptions about the user and introduce into the result set. Then something more that has nothing to do with the user, but about the availability of these items. So you don't want to show the user's items that are not available. Or the location, if the item is available for his location at all. So you need to filter that out as well. Or some business values that come from stakeholders. That also plays a role in the customer result set. So what you can combine is to build the query all together that takes all these inputs, all these factors together. So you need to filter out everything that is not available. You don't need it. Also, everything is not in this location. You also filter out. And then you combine the color and category together with the original query given by the user. And the boosting of these things, they go to different fields, right? Color is one thing and category is something else. So the user asked for sneakers that are white. He didn't ask for whites that are sneakers. And that's why you need to boost a little bit more for the category, because the color is a description of the item and not the other way around. So you set up a lot of boosts, a lot of filtering, and a lot of scoring functions. The scoring function is something that you can define on your own. How would recency play a factor in the result set? And how much of a factor would it go within the query? Similar to the business value as well. If certain promotional campaigns are taking place, or a certain brand has a certain score, and you need to design a function to combine all these together and give a result set that are relevant to the customer. And it's very tricky to tune these things up and down together. So a little is actually too much. One simple change in one factor can actually affect very, very much the whole ranking function. So you have different ways to create the relationship between these factors. You can add them up together, so stack them, or you can multiply them, which inflates the whole query. It's a matter of design and depends on your use case. So to give one example, I don't want to talk much about how to use things because the documentation is really good. Just go read it out and you can use it right away. It's the function score query, where you can just add a lot of functions and decide how they interact with one another. And you just define a function name and a filter and a weight of this function. And then you create a scoring function that works all together to find the best result set fit for a given user customer. So altogether, I talked about data enrichment, data ingestion, data retrieval, and ranking. And these together form a good search engine. What I want to say in the end that Elasticsearch is your Swiss knife for a lot of data problems. It fits in a lot of solutions, so the search problem is not the only problem Elasticsearch fits. There's a lot more for data analytics and much, much more. So I'm expecting from others also to share how they use it and what role it plays within your businesses. The final part is to talk about Elasticsearch and Zalando. So I wanted to give an introduction because I'm sure a lot of people are new to Elasticsearch on more of theory. And in Zalando, when we had a big monolith application and we wanted to break free and go into the new world and catch up with microservices. And our migration process involved to take every feature with us to the new world. And we had this awesome feature which is called Shop the Look, which is exactly what I'm talking about. It's a matching a customer with styles, not products, but styles. So our content creation creates one stylist put a set of items together and we form a look. And this look consists of different items. And our role is to make a search for these items where you can say, I want to find a look where there's a white t-shirt of size XL, material cotton, and occasion party. And you find all looks which fulfill this criteria. So you can imagine to get a little bit of inspiration. You can match this with already items that you have in your closet. And you can use this feature. We're still experimenting to get the best out of this feature. And to set these groups of items together to form this look, it was a challenge. And we evaluated a lot of databases. We evaluated graph databases, relational databases, and Elasticsearch. And it seemed in the beginning like a good fit for a graph database because this item can be in thousands of looks. So we wanted to optimize that we don't have a lot of duplicates. But you use different technologies for different use cases. And Elasticsearch works very well with denormalization. And we were fine with having a lot of duplicates because we were very happy with the performance of the service in comparison to the other databases that we evaluated. And to look on what we actually did is we saved the whole set of articles in one resource called a look. It's a grouping of all the items together, which has all the categories, the brand, material, occasion, all kinds of information that belongs to this article. And we grouped them all together and performed a search that you can with specifying one item, you get all looks that fulfill this criteria. And we found that if you use generic items like a white t-shirt or a black shirt, that you get thousands of looks in return. And it is not any relevant to show these looks that are relevant to this one. When you have 5,000, what relevancy does it play if you show all these looks? You just have to pick 8 of them. And that's why we developed a scoring function to fetch the more relevant results. So we designed a function that takes on one side Zalando as a stakeholder, and on the other side the customer looking for a relevant result set. So for Zalando, we wanted to show that only looks would show up here that is available on a certain sales channel. So for example, if you're buying on the German website and these products are only sold in the French website. So we need to downgrade these looks and not show them as the first top 8. And for the customer, we can boost up looks which have the customer preference of brand and size, gender, season, and style. So we developed the scoring function to fill up this place, and this is how we presented the feature. It's actually live, you can try it out. More to come in the feature in the future, but so far you can only find that on our product details page, where you have one item and just click and find all the looks where this item belongs. That was the first introduction where we used Elasticsearch, but it happened to be that for every new project or for every new data problem, it was a wild card that we played and it fit the solution completely. And one challenge was moving, as we are a product data team, we were responsible to deliver product data, not only for our team, but actually for the whole company, to use it as a service. And it was not about search. This was completely about fetching article data. And when you think about it, we needed to fetch articles only by SKU or by the URL or by family SKU, which actually is only the different colors describing an item. And just looking at the problem, so it's fetch, fetch, fetch. The first thing that would come up into your mind is to use a key value store. And that's why we ended up on Cassandra. It was advised by a lot of people, just build it with Cassandra. It scales, it's amazing. And we started implementation and we had a go live date and everything was going fine until we started to examine the different use cases and the different teams that we are supposed to support. And many use cases didn't fit. So for example, a special use case was the catalog page or the search page where we show 100 items. And for every item, we show 4 or 5 colors per item. So on this page, you need to fetch around 100 articles with their different 5 colors. So that's around 500. And this page gets around 1,000 requests per second in a normal time. So you can do the math that if you call Elasticsearch, if you call this service with an API, it translates to this amount of requests because it just goes as a key value store. You're fetching for every SKU, you're fetching sequentially. And this is when we knew that Cassandra does not help us in this case. So to get this amounts of requests per second, we needed a cluster of an enormous size. And having the knowledge and experience in our team, we already know how to use Elasticsearch. And this project did not have a real data problem. It was more of an operational problem, given the magnitude of the products we have and the amount of traffic that we got. So it was more of a scale problem. And to do it, we just created a simple service to just searches within the article for the 3 attributes that we said. Just fetch SKU, URL key, or family SKU. And our challenge then was to scale this service to based on the requirements of the different teams that we're supposed to support. And we've done a lot of performance tests to understand how it would work, and we found a lot of features that we can actually scale for every country based on its traffic, and it would work very well with Elasticsearch, that we can on the fly change the replication factor for a certain country and actually scale for it. Just add more nodes, it scales very well. With Cassandra, we couldn't do that, so Cassandra needed to scale up a manual intervention. I don't know how it goes with newer version, but the way it was used in our company, that if you want to scale, you need to do some manual work, And with Elasticsearch, we actually needed to do nothing. We set up Elasticsearch in an auto-scaling group, and we let it auto-scale. Luckily, we're on the cloud, and we can leverage this way of doing things. And I will not share how many nodes we have to handle our traffic for the article service, but I can say it's a lot of traffic, it's a lot of teams, it's facing customer applications, and it's facing a lot of services. And we designed it to be, through performance testing and trying things out, we designed it to be that every instance on Amazon has, in the normal case, in the low traffic case, 3 shards per node. And this allows us, so having this in an auto-scaling group, just with the high traffic, more nodes automatically scale up, and these shards will go to the different nodes, ending up that you have 1 shard per node. So we can actually 3 times scale up automatically without any manual intervention. And this was a good USP to convince our bosses. And we really had to go into a lot of discussions to convince our company. Elasticsearch is a new technology here, and we had a lot of discussions to convince our bosses that it actually works, and we can keep it and rely on it as a foundation for serving data to our fashion store. Finally, in our team, we built 3 services. The reviews, I will not talk about it because this shows the aggregations. It needs a talk on its own. And we serve the products data for our team and different teams, and we solve the fashion problem for Shop the Look. And in the company, we have a lot of other projects. And what we did, so to convince the people that we actually can go live with these services. So some features are fancy, just to have customer reviews or Shop the Look. These are fancy features that are not the foundation of running the fashion store. But the product data, this is something that is not up to negotiation. So scaling is not a question, and availability is also not a question. And that's why we needed to have a solid setup on how we use Elasticsearch on Amazon. And that's why we developed Elasticsearch Express. It's an internal application or service that you can deploy Elasticsearch with the right configuration. Everything is automatically configured within 10 minutes. And Elasticsearch allows you to set configuration to accommodate to the environment that you're in, whether you're on hardware or on the cloud or on which cloud provider. You can set configurations to accommodate for the failures that might occur. And as we are on Amazon and on a specific region which have only 2 availability zones, we decided to split the data, to guarantee that the data is split between the 2 availability zones, so that if the link between the 2 zones is gone, or whatever zone just goes away, that we are able to with 1 zone, to handle the traffic and catch up and actually replicate and go to the same state that we were with 2 zones. We have done a lot of testing to see how this works and to try to simulate failures and to guarantee that our service can actually recover automatically without our manual intervention. And I wrote an article about how we did this, how we set up Elasticsearch Express on Amazon. It will be on our Zalando Tech blog in November. Finally, to convince the people in Zalando that this technology can work and we can support different teams to use it. We have this institution, the Tech Radar. It's a committee that takes from the different teams the evaluations and their knowledge and their experience from different technologies and decide whether a technology is between on trial, assessed, on hold, or adopted. And after these set of projects, we were able to move Elasticsearch to adopt, and now Elasticsearch Express is being used in different teams, and we're giving a lot of trainings and sharing a lot of knowledge with the others to help them meet the requirements of the large-scale cloud. Finally, there's a workshop. It's about data search relevancy. Specifically, it's trying queries, trying different techniques on real data sets. And if anybody's interested, just go to the website and subscribe to it. I think we have time for 2 or 3 questions. Probably you need a mic.
For your speech. My question is, how do you measure relevancy? You talked about user input and feedback. How do you measure relevancy, and how does this show up in your own models or in your own Elasticsearch? How you do you feed it in back then into Elasticsearch?
It's a bit tricky how you measure relevancy. So this is a little bit outside of Elasticsearch where you need to. This is a little bit outside of Elasticsearch. How do you measure the quality of your search results? We are now deciding in the search team to use things like measure the click rate on the first top items and look how many people click on that, and also see the bounce rate after people click. Do they actually put it in cart? Do they actually buy it? Does it happen till the end, or do they just open it and go away? So there's a lot of scenarios on to decide the quality of the clicks on search result items, and this is how we measure it. And the way to guarantee a smooth transition from a ranking algorithm to the other is it's about A/B testing and checking results, whether people respond to it positively or negatively. If not, then we roll back.
Okay. Thank you.
Yeah. Maybe pass the mic.
Hi, actually I have multiple questions. So the one thing I'm interested in, did you evaluate the Amazon managed Elasticsearch cluster, and what do you think about it? And the second question, maybe, you expose maybe a very, 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 very big Elasticsearch cluster, and you have then a lot of services using your single database. So have you thought about something like Hazelcast? Because most Hazelcast, like a caching, because it seems like you scale up your cluster very big, because actually you have to serve a lot of traffic, but actually I think it seems like a cache.
For example, talking about the product use case for this service, we use it exactly as a cache. It's actually a cache. It's aggregating. It's actually aggregating the data coming from different backend services and putting it all together to provide it for the customer-facing applications and other services. So it actually works as a cache in this use case specifically. And the first question about using AWS, at the time when we evaluated, it was still version 1.5, I think, and already version 2 was out. And we heard that you're not able to scale up with the Amazon solution. I'm not sure this is true, but nevertheless, we wanted to have full control on our cluster, how it scales, how we monitor it, and get full control on management. Maybe.
How many indexes do you have per shard? How many shards do you have per index?
I will not talk about how we split the data, sorry.
Thank you for your talk. So in the ranking part of your slide, you talked about basically understanding what price range the user is interested in, right? Normally the Elasticsearch is user agnostic. So how do you handle that in Elasticsearch? Normally the Elasticsearch does not know about the user, right? So it basically, you use it for your product data,
yes,
which is user agnostic.
But you know about the user. Elasticsearch doesn't have to know about the user. So you can set up in this part of your query. So if you know this user and you know his favorite brands, his favorite pricing scheme, you can attach this into your scoring function.
Thanks.
That's it.
Where in the process do you use machine learning?
Sorry?
Where in the total process do you use machine learning algorithms?
In these projects, these are about serving data for customer-facing applications for the Zalando website. The search engine behind the search page is actually in development yet, so it's not yet live. So this new team that I talked about, it's called Query Search and Intention, and it's more dedicated in the direction of machine learning and data science, but we have nothing yet live. Yeah. So I have, just ask me around. I'm going to be around here. I can have a 15 minutes break before my friend Thomas from SoundCloud will give a talk. I'm very excited about it. Thank you.
Did you think about putting customer preferences to the Elasticsearch as well? Not yet, but so you don't have any aggregation, so you keep all this data prepared somewhere. How do you manage to the data? Customer preferences, for example, brands.
Regardless of the you can ask the API, I want to pick some white t-shirt, size material, boost these materials, these brands, for example. Put those slides to be accessible. Thank you very much. I just started with I found some question answer that I've had on my own so far. So we came up to Elasticsearch evaluating other solutions.
Now we're trying to
drop me any questions. Do you think it's a good idea if you got relation with database, convert it into a document, put this the original data? I would like to make a denormalization of the original ES data and make it just with that and put this into it's not good anything. It's very volatile. I wouldn't consistency is a bit tricky. No, I wouldn't. So you what we should not on one level, so we can test objects, of course, but not less in group. We need less again, but we group, we not normalize big tables. So this is how we if you really measure for the speed, you get speed, you don't want to control. Because if you join, then you have to do your application side joining. That's one index.
So it has different tokens.
That's a good question. The original you have to denormalize anything. You want to search this. You can have all kinds of attributes. You need to fetch this item.
So you don't have separate indexes for all your categories.
You need to duplicate some attributes to bring the item to color, different fields, and different forms, and group them together in some say
maybe it's blue and also dark blue. So you put both. Like somebody writes blue, it's right. If somebody writes dark blue, it's an exact match. Even match more. So sometimes you have to duplicate within the resource much. So we do
and you have to bring in data. Black and white, making the consistency of that. Even if the task to denormalize the data is a huge thought, and it takes a lot of time.
It doesn't matter how much time it takes. You need to keep this original part of your data outside of Elasticsearch. It's different for search analytics. It's not built for storage. So use it where, this is what I said in the beginning, know what your technology can do and what it can't. So it's not consistent. It's not guaranteed that it's a distributed system. It runs all the nodes, same data, maybe you updated a product, and it is not so but you have to update your index. If there was a change in your original data, then you have to make an update of your index, right? This effort is much more or less than indexing algorithms. It's much faster. It's not, the update is much faster than indexing in the first place. If you have an because when you update, Elasticsearch does not update your resource, it marks it on the right side. It's exactly as I would.
Like 90 max 3. So how do you do that? Because users can actually type air space max space 3 I LLL and 3. So do you like the complete project like Nike Air Max 3, but user actually can put 3, they can put LLL without checkbox. The same as Roman, you know, like they can so how do you think? Because like it's just a specific product, but if you have like thousands of products, do you have like a set for each brand? Like
Let's say this consists of people. You can use a single tokenizer.